Hello, we are reviewing the range-based for loop. I just showed everyone that in order to change elements, we have to have the ampersand in front of the range variable. That's the I here in the for loop. And if you don't need that, if you're just like writing or reading from it, then we get copies. You can change the range variable that's a copy of the elements in the array, but that will not affect the array. So if I do not have the ampersand in front of the range variable right here, like no ampersand, and I run it, the array doesn't change, stays the same. The I changes, right? So I do have I as 7 here, and if I printed I, it would still be 7. But if we change that range variable to a reference variable by putting an ampersand in front of the variable name, and when I run it, our array has changed. Wah, wah, wah. Okie dokie, let's move on. So here's an example of these. Oh, so we just saw this one. We're using an example of range-based for loop. We talked about this, putting reference variable in. Program 712 demonstrates that. So now in the for each loop, they have a reference variable val, which they then ask the user to enter. So this will then enter an element of numbers, and numbers is this integer array that was not initialized. And because it's local and it's not initialized, the numbers currently in number are undefined until the user enters them with the cin state. And they print them out using a range-based for loop. Notice this one does not have an ampersand in front because all we're doing is printing a copy of the element. You can use the auto keyword. We talked about auto, and auto will try to figure out what type the array has from the array's declaration. So here, the high array has integers in it. So if I change this from int to auto, it should try to figure out what kind of elements are in the array. Auto. See what happens here. No errors. We should get the same output as before, where the array changes to 7, and it did. So auto can try to figure things out. Maybe we can change this to string and see what happens. String. Or let's make it character. Character array. Instead of 1, 2, 3, 4, 5, we're going to do the letter 1 and the letter 2 and so on. The letter 3. Oh, this is not going to be very much fun. The letter 4 and the letter 5. This is not going to be very much fun because I am not really changing the output, right? I can print a single digit as a number or a letter. The letter 8 and the letter 9. And down here, instead of changing to a 7, we'll change them to the letter B. Why not? Something's wrong. Period. And here we're changing the value 7. That should still work. See what happens here. No errors. And they all turn to B's with the auto. So auto will try to figure out what type it is. Here auto is figuring out that it is a character and not an int, although characters are 1 byte int. Shh, don't tell it. When you print a character, though, see how it prints it as the letter. It looks it up in the ASCII table. Next one. Range-based for loop versus the regular for loop. So here they're giving you some advice as when to use one, when to use the other one. Range-based for loop is fairly new to C++. When I learned C++, they didn't have one. And so I had to use the index-based for loops. And so I rarely use the range-based for loops simply because I never practiced doing them. However, they do have some benefits. As we see, I don't need to know the bounds to write the contents of a whole loop. And if we're doing simple things like just printing them, a range-based for loop is ideal. So I might use the range-based for loop from now on for just printing, doing easy stuff like this. But it does hide that indices. And again, beginning programmers make that indexing mistake all the time. So do what you think is best for you. Let's see what the slides say. The range-based for loop can be used in any situation where you need to step through the elements of an array, and you do not need to use the element subscripts. So if you're doing a swap, range-based for loop will not work. because you can't get back. Once you pass an element, you can't get back to it. You can with indices. You can do a swap with indices. If you need the element subscript for some purpose, use the regular for loop. And that is it for the range-based for loop. Next up is processing array contents. And so there are certain actions or algorithms that are used very frequently with arrays. So here's one. Array elements can be treated as ordinary variables of the same type as the array. When using the increment and decrement operators, don't confuse the element with the subscript. So notice where that plus plus goes. In the first line, the plus plus is incrementing the element at index I. And the second one, it's post-indexing or post-incrementing the index itself and accessing the element at I. So we access the element at I, then we increment the index. And the first one accesses the element at I and increments it. They're slightly different. Array assignment. To copy one array to another, don't try to assign one array to the other just like this. New tests get tests. It won't work. What it might do is give you an alias to the old tests. So we have new test equals tests. Let's try that. So we have a character array high, and I think I have to do it as a character star. Character star by equals ampersand high. I think I have to do it that way. Oh, it's bad. Cannot figure character 9 to character star in initialization. So maybe we have to do it differently. Let's try it this way. Character by gets high. Nope. Initializer fails to determine size of by. Okay, so it's not working. Can we just say character by semicolon and then by equals high? Nope. Error, storage size of by isn't known. Can we specify it? It's a 9. Error, invalid array assignment. It won't let me do it. Wah, wah, wah. All right, so you can't do that, right? You can't do it. It won't let you. That's too bad. Instead, we have to assign element by element. So if we have two arrays, a high and by, let me get by back and get rid of print array here. Character by of 10. Let's say I wanted to add the 0 to high. High only has 9 elements, and I use them all up. How can we make it bigger? Then we need a for loop. For int I equals 0. I is less than 9, which is our magic number for the size of array high. I plus plus. And then we just say by of I gets high of I. And then we can print our. So here I'm printing high. Let's hit I'm printing by back here. Auto ampersand and by. All right, let's see what happens. No errors. Notice what I'm doing with this for loop. I'll pop it out here. I'm just copying the value that I find in high into the same element number as by, so the same index. So my first element of high should become my first element of by, and so on. Then I print high, then I print by, and notice that by is bigger than high by one element. Let's see what happens. I don't see anything. All right, so there's an unknown character here. Oh, we do see something. So here I'm just clicking and putting the cursor at the end of the output string. Here, 9 has a space after it, and here 9 has like 4 or 5 spaces after it. So one of those spaces is the character at position index 9 of by, or in the 10th position of by. It's hidden. And that's kind of what happens. So if I need to make my array bigger, I have to create a new array that's a larger size, like I do here in line 22, and then copy the old array into the new array. So it takes time if you're making an array bigger. And you would want to make your array bigger if your original array doesn't have enough room for what you want to do with it. And you find out later, oh, I need more space. Let's make more space. Printing constants of an array. We could try this print. Notice here we have an array named Henry as a character array, and then we print it to see out. That'll actually work. But what won't work is if you have like an integer array and try to print the integer array to the terminal. So let's try that. Integer high by gone. Bone? Okay, bone. We don't know how big it is. I'm going to put the values 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 in it. And we just print out. See out, bone, and line. See what happens. There's our bone at the top. 0xCD57DFF920. Can someone tell me what that is? Nobody knows? That's the address of bone, or the base address of bone. If we want to print out bone of 0, you can do that. Here's our 0. So we can't print an array directly unless it's a character array. So let's print that character array high and see what happens. When I printed it after bound, there it is. 1, 2, 3, 4, 5, 6, 7, 8, 9. Look, it works. And that's because cout knows how to print what are called C strings, and a C string is a null term array of characters. And what high is an array of characters. And so it keeps going through high, and it keeps going. And let's see how far it went. Oh, it ended right there. And then it found a null, or a \0 at the end of high. And so it keeps printing characters until it finds a \0 character, and it doesn't print it. So it printed high just fine, but it didn't print bone just fine. So do note that in order to print an array, you have to iterate through it, and we do that here with these for loops, right? Iterate and print each element in turn. So when we print an array, you print each element in turn, and that's why I made these print I array and print C array functions. For other types of arrays, you must print element by element, which I did. In C++11, you can use the range-based for loop to display an array's contents as shown here. So here they're printing out each integer in numbers using a range-based for loop, which is a good use of a range-based for loop. Summing and averaging array elements. So here's some activities that are very common and done a lot of. Summing array elements or averaging array elements. So here in bone, I have the numbers 0 through 9. What is the average of all this? Can someone tell me? Of bone, what's the average? This one. What'd you get? 4.5. That's correct, 4.5. How'd you get it?
Just 1 by 2 over 10. Oh, well, you can do that too. 9. 9. 9. Yeah. Of 10. Have a 9. I just took last number n and then did that into n.
Oh, okay. So 0 to n. Okay.
Yeah, and then so n into n plus 1. to get me 9 into 10 by 2. So it's 90 by 2, which is 45, and then 45 divided by 10 because that's how many.
All right, very
That's
good.
a very long way to go.
That works. All right, so to create an average, we need to average is the sum divided by the number of terms, correct? So since we know that bone has 10 elements, I'm going to say bone of 10, so we remember what it is. What we can do is add them up. I need some kind of summer, right? Int sum equals 0, and then we have an array for int I in the bone. We're going to add to the sum plus equals I, and then we're going to divide by a cout. Average bone is, and we need to convert this to a double sum over 10. Build. So we get that 4.5 to show up. There it is. Average bone is 4.5. Voila. So this is an algorithm you'll use a lot. Find the average of my numbers. And you store the numbers in an array. You have to use a for loop to sum all the numbers up. So you go through the array, adding all the numbers together. And then once you get the sum, you divide by the total number of numbers, which is what they do in the slide. Although they made their sum and their average doubles. And what do we have? Tests of num. I think num is still the int array. Summing and averaging array elements. You can use a range-based for loop, which is what I did. To sum it, we can also use the indexed for loop. Do we have it here? We do. To do the sum. But now we have something different. Finding the highest or lowest value is another algorithm you'll do. So, cout highest of bone is highest n-line. But highest doesn't exist. So let's make it exist. Int highest. And let's get it to start at something really, really tiny. Negative. Blah, 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 blah. Hopefully that'll fit in int. So then what we do is we go looking for the highest value. For, oopsie, what happened? There we go. For int I in bone if I is greater than highest becomes I. Then print out. Let's see if it works. Highest bone is 9. That's right so far. Let's change something in 9. Let's make this one 13. Try it again. This will change my average. Highest bone is 13. It's working. Same thing for lowest, right? If we do a less than, we get lowest. We can get highest and lowest in the same for loop, and so on. Notice that I'm starting highest at a very small number. And it would be nice if I started highest at the smallest number possible for an int. So we could look that up. And I think they have it somewhere. C++ smallest int. They list it here, but that's no fair. Int min, here we go. We have something that's called C limits. Here am I. I'm in the AI overview. If I don't know where it grabs this from, doesn't say. But anyway, here we have something called C limits, and inside C limits is a constant int called int min, which will hold the minimum value. So we grab C limits, pound include C limits, and then instead of my guessed at smallest number, we use int min. We can be rest assured that there is no integer smaller than int min. We can even print it out and see what it is. All right, so the highest bone is 13. That works. And our int min is, let's say 1, 2, 3, 1, 2, 3, 1, 2, 3, 2,147,483,648, which is the large or the smallest possible number you can put in a signed integer. And since we started our highest at the smallest possible number, there are no numbers that are smaller than it. And so we can't miss the highest of our array. We can make these all negative. I don't know if negative 0 is going to work. We'll find out. Didn't complain. Highest, oh, we got some question marks here. Highest to bone is 0. Average bone is negative 5.5. And we got a 0. What's that 0? And a crash. We got some weird, oh, I know. So notice I was printing a C string. Where is that C string being printed? Right here. Print high. And high ends at a null terminus. And now we have these question marks, which happen to be these values that I'm sticking in my other array. So there's an array after high now, and it will print through the array until it finds a null terminus. So we get these question marks showing up the way it's working. So possible minimum is that. Highest to bone is now 0 because they're all negative, and the average is negative 5.5. So do be aware of these C limits. C limits allows you, has, min, max, and that's a number for ints and doubles and so on. In case you want to do these min-max things. And this is all because we want to know how do we find the highest. And again, to find the highest, we use a for loop to look through everything in the array. And if the thing we're currently looking at is bigger than the highest that we're remembering, we make that remembered highest the new thing because it's now higher than what we remembered. So you can think of this as, what do you call it? King of the hill, right? So highest is the king of the hill. And here comes some guy up to challenge the king, number I. And number I says, I'm higher than you. And if I is indeed higher than you, they knock the king of the hill off the hill and become the new king of the hill. If you guys know what king of the hill is. Yeah. So that's kind of thing what's going on here. You have a whole array of numbers coming to be the new king of the hill, and the old king of the hill says, nah, I'm bigger than you. Or, oh, you're bigger than me. You become the king. And the same kind of thing for the minimum. All right, back to the slideshow. Find the highest value. So we're looking at the slide. They do the same thing. They have this numbers of 0 for count I equals 1. Interesting. Why are they doing that? Oh, because they do this, right? Int highest. Highest gets numbers of 0. So we're making highest the very first element in the array. And then we go through the remaining elements. We start at 1. And if this new element is bigger than the highest, it becomes the king of the hill. And this way we don't need to use the int min. Don't need to know what's the minimum value. Same thing for lowest, only instead of a greater than sign, we use a less than sign, right? The only difference is that one right there. Greater than or less than. Right, we can go back and forth, right? Greater than, less than. Greater than, less than. Partially filled arrays. It is unknown how much data an array will be holding, and here they give you hints. Make the array large enough to hold the largest expected number of elements, and use a counter variable to keep track of the number of items stored. So let's do that with bone. Actually, let's do that with something new. Int something new, and something new is going to have 5 elements in it, but I'm going to give it a space for 100 elements. And I'm going to say it has the array 1, minus 7, 22, 0, and 14. And we print it, oopsie, for int I in something new, something. Actually, we need a count here. int something count equals 1, 2, 3, 4, 5. So I'm not going to use a for each loop here because I don't want all 100 to show up. I just want how many I think are currently in there. So int I equals 0. I is less than something count. I plus plus. See, there we go. Cout I and a space. Cout end line. Warning, unused variable something new. Oopsie. Something count. Oh, I'm sorry, it's not I. Cout, it's something new of I. Something new of I. That's what I wanted to do. Sorry. There we go. I got too much junk showing up. It's like stuff I've used before. I don't want to see it. Here we go. Something new. 1, -7, 22, 0, and 14. 1, -7, 22, 0, and 14. Uh-oh. Let's say I wanted to add something. Remember here I had the by. And by had 10 elements, and I had to copy the elements from high to by. If I wanted to add something to the end of something new, I can just do this. Something new of I plus plus. I'm sorry, of something count. Something count plus plus gets a new value, 66. And two things are happening there. Do you see both things happening? All right, let's take a look. My original something new had 5 elements. 1, -7, 22, 0, and 14. I wanted to add the element 66 to the back, and so I did that with this one-liner right here. This one-liner does two things. It puts 66 at the back of something new, and at the same time increases how many elements are known to be stored in something new. So up here we have something new. It could hold 100 elements, but right now it's only holding 5. And I remember how many it's holding with the something new count or something count. I use a for loop. From I equals 0, I is less than something count, or the size of something new, to print that something new element. And we see the 5 elements originally. Then I add a new element. And to do that, I have to write the new element at the back of something new. And the back of something new is the size, which is something count. So I put the new element at something count. And then now I have a new element in something new. So it should get bigger. It gets bigger by 1 with the increment operator. Right there. And so we are adding an element to the back of something new, and voila, we add an element to the back of something new. Notice the 2 prints. There's one print algorithm. There's the other print algorithm. And the 2 print algorithms are identical. And that's one way to make your array bigger. And to be allowed you to make your array bigger, you start out by asking for an array that is bigger than what you need. And then you just use what you need until you need more. And once you need more, then you can use more as something count got bigger. Alrighty. That's what they're saying here. Partially filled arrays. So I can write this here. Right, so it's partially filled arrays. And they say it over here in partially filled array. Make the array bigger than what you need and use a counter variable to keep track of how many you're actually using. Partially filled arrays. This actually is how the vector works. And so we'll see a vector. A vector is an array that you can expand or contract at whim. And the way it works is by it has an inside array that's bigger than how much you think it is. And when you want more, it just uses more of that inside array. And if you want more than the inside array, it makes the inside array bigger. And when it does that, it copies the values over like this. And this step here, this copy values from one array to a bigger array, is slow. So the whole idea of the arrays is to give you instant access. Right here, I'm printing bone of 0 instantly. I can print any of the bone elements instantly with that index. And it jumps right to the index. So that's super fast. So reading and writing arrays are super fast. The one thing that might not be super fast to an array is making them bigger, asking for more than it is. In order to do that, we have to, here we go, make a new array that's bigger than the old array. So bi is 10 and the old array high is 9. And then copy all the elements, oopsie, not that one. Here it is. Copy all the old elements from the old array into the new array. And that step is slow. All right, so that's partially filled arrays. Here's comparing arrays. To compare two arrays, you must compare element by element. When you're comparing arrays, I think like a not equals is the thing we're shooting for, not equals. But if you go not equals directly, it's going to compare their addresses to see if they are in the same place. And what you want to do is do a for loop like they do here, or a while loop, and say while arrays equal and count as less than size. If the first array element is not the same as the second array's element, then arrays equals is false. It's no longer true that the arrays are the same or contain the same or equivalent elements, and then we can quit. So count increments, and then we exit because arrays equal is no longer equal. So that's how to compare two arrays. You want to do a loop element by element. Structured binding declarations. What the heck is that? Oh, I see. Okay, this one I haven't used. It's pretty new. It's in C++ 17. I think I stopped learning at C++ 10. And so a lot of these things are new. This one's new to me. Here we're creating a whole bunch of variables. So it's like declaring a whole bunch of variables that contain the contents of the array. I don't know why you would do that, but here they're doing that. So something new has 100 elements. Let's find some other one. A bone. We can do it with bone. So that'd be something like this. Auto bone 1 comma bone 2 comma bone 3 comma bone 4 comma bone 5 comma bone 6 bonus 10, lovely, comma, and go to the next line. There we go. Bone, where we're at 7 comma bone 8 comma bone 9, one more, comma bone 10, square bracket, equals bone. And once we do that, we can print cout bone 3 end line. And this one I don't know if it's going to work. Let's find out. A bone 3 equals 33. I don't think they're aliases. Let's see. I think they're copies. Where's my bone? Bone is, we're doing highest, minimum possible is, so I have 33, which is the maximum. Highest bone is still 0. So after I've added the bone, where did I print 33? Did I print 33? I didn't print 33. I print bone, that's minus 2. That's bone number 3. And then I change it but I don't print it again. And so this -2 is bone 3, or gets copied into bone 3, and then I change bone 3 to 33. But we see when I print bone down here somewhere, where's bone printed? Oh, I print the average. Average of bone is the highest of bone. Here we go. The highest of bone is, I print the highest, but bone 3 is a different variable than the third element of bone. And the way to copy all those elements out into their own variables is with this structured binding declaration. This thing here on lines 25 and 26, which I never used because I didn't know about it. What happened here? There we go. So I don't know why or when you would do this. I think it's useless. Maybe you're parsing strings and you get a string and you chop it into little strings. Maybe that's when you do it. But why make all these different variables by hand when you don't have to, when you have an array and you can access each element directly? Why make new variables? So here's an example of the book using it. We have test scores, has 3 values, 80, 90, and 100, and then we change those in different scores with the was a structured binding declaration. So we make 3 new variables, score 1, score 2, and score 3 with test scores. Now, I don't know what happens if we make it the same variable type. Can we do int, or does it always have to be auto? Structured binding declaration cannot have type int, so it has to be auto. See if I can spell auto correctly. There you go. That I didn't know. Again, I never used it. Looking at it, I have no idea why you would use it. All right, where are we? 7:44. I think it's time to stop and do a lab. So let's take a little break, and then when we come back, we'll do the lab. And then we'll talk about parallel arrays, which I absolutely hate, and we'll see why I hate them. And that's it. Take a little break.